Hi, welcome back to Math 8. This is a video over Section 2, and we're going to be talking about the overview of transformations, okay? So our objectives today, we want to identify the types of transformations and relate the result of a transformation to the original figure. So let's talk about a transformation, okay? A transformation is an operation on a figure that may change the figure's location in a plane, its orientation, or its shape. Okay, and we've got four kinds of transformations, okay? We've got four kinds, all right? So four kinds. We have what's called a translation, all right? And a translation is a slide, okay? And I'll talk more about all of these here in a minute. The next one we have is a reflection. Okay, and that's, I use the word mirror. We have the word rotation. Okay, rotation, there's an I in there. And that is, I like to think of a clock. Okay, and then we have what's called a dilation. Okay, and that's something where we change the size. Okay, and so, really what you have here, these are all the things that we would do on a figure if we wanted to either move it in some way, and by moving it, we can do that using a slide, we can mirror it, or we can rotate it using a, clock idea, or a dilation means we change the size, okay? So, and that's the idea here. And if you look over here, if you think about these figures here, here's your original figure, okay? This example here would be a translation, okay? All you're doing is sliding this over. Here's your original, all you're doing is moving it over. This one over here is a reflection. Okay, it's like a mirror of the original. All right, so here's your original, here's your mirror. Okay, this over here is a rotation. All right, so this guy would be a rotation. All right, the orientation has been changed. It's, here you have your right angle that is down. Here your right angle is up, okay? And then the last one would be a dilation, okay? Now, what you can also think about, you're probably going, well, wait a minute. Couldn't you also say that this would be, if this is your original and, here's your rotation, could you also call that a reflection as well? And the answer to that question is yes. Sometimes we use a combination of transformations to move an object, and that's what we're going to be talking about. Okay, so the first thing we want to talk about is translations. Okay, translation is a transformation of a figure on which every point moves the same distance in the same direction. Okay, remember a translation is a slide. Okay, however, we can move things, left, right, up, or down, okay? And so, sometimes we move things on a diagonal, okay? So what we do, and the figure retains the same shape and size as the original. This is really important, okay? When we do a translation, the figure doesn't change size, all right? We have the same shape, it's just simply moved over, all right? But what I want to talk about here is the act of taking each of these points on my original and figuring out, how do I move this point all the way over to here? How do I move this point all the way over to here and this point to here? And what we have to do is we have to move vertically and horizontally. So vertical, let's write these words down. Vertical is up or down. Okay, and then horizontal is left or right. Okay, So when I use those words, vertical and horizontal, I'll use up or down, left or right, and that's kind of the same idea, okay? So I have a vertical movement here, all right? And I want to use like a, go up and over or down and over in some way. And so what I would do is think about this, and I'm going to go, okay, to get from, my original point here to this point here, I have to go up and over to get to that point, all right? So I'm going to go up 2 units, and then over 4, okay? Here, I would go up 2 units and over 4. Here, I'm going up 2 units and over 4 to get to my next point, okay? So in this translation, what I'm doing is I'm going, my vertical movement is up 2 units, and then right 4 units, okay? And that tells me, this is my rule that tells me what I'm doing, okay? So this is my rule, all right? All right, let's talk about reflections. Okay, so a reflection is a transformation in which a figure appears to flip, and I like to use the word mirror. Okay, if you've ever seen the original Batman, whenever I hear the word mirror, I think of that scene where Jack Nicholson transforms into the Joker and he screams out, "Mirror! Mirror!" Okay, all right, but a reflection is a transformation in which a figure appears to flip, so a mirror. All right, and so what we have is every point on the graph is moved over a line so that each point and its corresponding point are equidistant from that line. The figure retains the same shape and size as the original. That's important. Things don't change size when you flip them or mirror them. So if I look at this, the couple things I have to talk about when I talk about a reflection, okay? I have a line of reflection. So I'm going to draw that in here and call this my line of reflection, okay? And this is my original triangle here, all right? And we mirror that over to the other one. Now, each point on this line is going to be equidistant to my line of reflection as its line in the corresponding side. Okay, so this point corresponds to this point here, all right? And this is a distance of 3 units, okay? Now, if I look at the corresponding point over here, this is also a distance of 3 units, okay? Now, the same thing can be said down here with this point here and this point here. They are both 1 unit away from the line of reflection. Now, same thing with this point and this point. Those are both 1 as well. But that's the idea, is that, you reflect this line over and it's like a mirror, okay? And so this point is going to correspond with that point. It's going to be the same distance away from that line of reflection, and that's what we talk about here. Okay, rotations, more like brotations. A rotation, and remember, I think of a clock, okay? Like the hands of a clock. If you watch a clock, like a dialed clock, you see these arms rotating around a center, okay? And so what you have here, as I look at this, a rotation is a transformation in which each point on a figure is turned through a given angle and direction around a given point, okay? Again, the figure retains the same shape and size as the original. I keep saying that, all right? So the cool thing is that whenever you do a transformation, is that things don't change size, all right? That only happens when you do a dilation. We'll talk about that next. But what I want to talk to you guys about is this, all right? If I wanted to, and I'm going to write this down, we're going to rotate 90 degrees counterclockwise, okay? And if you're confused on counterclockwise, counterclockwise goes in this direction around a circle, okay? And so our center of rotation, or brotation, is at the origin, okay? And that's the point 0, 0. So center of rotation is the point 0, 0. All right, so here's my center, okay? And what we know is that each of these points correspond to the other using this rotation. So they're going to be turned the same direction by the same angle, which in this case is going to be a 90-degree angle around the center. Okay, so what I want to do is locate this point here and its corresponding point here. Okay, now if I draw lines that go to the center, okay, I have a 90-degree angle. Pretty cool. Okay, now if I talk about this point corresponding to this point, all right, here's my line here, here's this line here, and again, that makes a 90-degree angle. Pretty cool. If I talk about this point that corresponds, this point here that corresponds to this point here, again, thinking about how that relates to the origin, it makes a 90-degree angle, okay? And that's the idea, all right? And so all we're doing, guys, is we're simply just looking at the pictures and wanting to identify, basically what's happening here from one figure to the next. Are we doing a translation? Are we doing a reflection? Are we doing rotations? Now, they all have various properties to them, but we don't have to sit there. We're not going to go into that yet. We're going to do that in the next couple sections, okay? But right now, we're just identifying what these look like and just some vocabulary that's associated with each of these. All right, let's take a look at the last page. All right, so a dilation is something where they change size. All right, so I'm going to write in here that they change size. Now, if you've ever seen the movie Dumb and Dumber, there is a scene where Harry and Lloyd are they're in the van made out of a dog, and they're driving across the country. And Lloyd makes this statement. He says, Harry, according to this map, we've only gone about 2 inches. And that is an example of a dilation. Okay, a dilation is exactly that. Like, it's a scaled version of what you're looking at. So if you're looking at a map, that's a scaled version of the Earth that we're on. Okay, so that's the idea. All right. So in dilations, okay, is a transformation that changes the size but not the shape of a figure. Dilation can result in an enlargement or reduction of the figure. Okay, so what I want you to do is look at this one here, and we're going to talk about the one that's in orange and the one that's in green, okay? And so this is our original, and then here's our dilated figure, okay? And what I want you to see is that we had an original length of 2. And then after we dilate the image, we get a length of 1, okay? I want you to look at this side here where we have a length of 4, and then all of a sudden we have a length of 2, okay? And so thinking about this, going from 2 multiplied by some number n, which we'll call the scale factor, gives us 1, okay? Is equal to 1. Okay, also the same thing happens where we've got some number 4, multiply that by a scale factor, and that's going to give us a value of 2, okay? So what we can do is we can actually solve this equation for n, pretty cool, divide both sides by 2, and we get that the scale factor is 1/2. Here, if I divide both sides by 4, I get n is equal to 2 over 4, which n is equal to 1/2 if we simplify that fraction, okay? And that's our scale factor. So we are actually doing a reduction in this example, okay? And you can see that we're by a scale factor of 1/2, okay? And we'll talk more about that, but that's the idea, okay? So, essentially what I'm doing is I'm taking each of these sides, multiplying them by 1/2, which gives me the resulting sides, okay? So when we're transforming figures, okay, whenever a transformation is performed, 2 figures appear on the same plane. And what we want to do is we want to figure out which one is the original and which one is the result of the transformation, and which one is the result of the transformation. All right. So, and in this example, I typically I don't have a way for me to do it. You know, when I made this video, as you can see, I chose the ones in orange on the video, because yours is probably black and white on your paper. But when I did this, what this showed me was that, you know, I just chose the orange one to be the original, okay? And which one is the result of the transformation. All right, and what we do is we call that the image, okay? The image is the result of the transformation. Okay? And in this example, they just completely screw me up. Oh, no, we're good. And the pre-image is the original. Okay, good. Thought I did it backwards the whole time. Okay, so the original figure on the plane before the transformation is performed is called the pre-image, and that's the original. I often will call that the OG. Okay, and then the result of the transformation is called the image of the figure. Okay, so that's the idea. All right, so here's what we got. So, and what we do to indicate this, to indicate which one's the image and which one's the pre-image, is we use this thing called prime notation. So prime notation is used to indicate that a figure has undergone a transformation. The apostrophe is read prime and indicates the image. So A prime, and that's how I read this, A to the apostrophe is really A prime, okay, is the image of point A. So what I would do here, you know, if I were to call this triangle A, B, and then C, all right, this is on my pre-image. On my image, after I've done, and this looks like it's a translation by going up 4 over 3. Not going to write that down, but over here on my image, okay, I would label this as A prime, B prime, and C prime, okay? And that's the idea, all right? And you could do the same thing here. You know, if you've got your original point here, you go up 2 over 1, 2, 3, 4, 5, okay? This is your original, this is your result, okay? This is your pre-image, this is your image. Okay, and let's move over to the last page on this assignment, or these notes. Okay, so using prime notation. Use prime notation for the transformations of point segments, triangles, or other figures. Corresponding pre-image and image points are listed in the same order. So the pre-image is AB, okay? And this is, I'm going to call my pre-image, also known as the OG. And then this is my image, okay? And I call this the result of the transformation, okay? And so, you know, what you can say here is that, you know, this is simply just moved over, okay? And so we would call this a translation, all right? A translation of AB, line segment AB, to line segment A prime, B prime, okay? And that's what we're looking at, all right? Now, over here, okay, the transformation maps a figure onto its image. The arrow is used to indicate the mapping, okay? And that's what I did here, okay? So to go from this to this, I use that arrow, okay? And that's where I would use an arrow, is to talk about a transformation. Okay, so a transformation maps a figure onto its image. One arrow is used to indicate a mapping. So A to A prime is read as A maps to A prime. So corresponding angles are listed in the same order in a mapping, such like as the congruency statement. So even when I talk about a congruency statement, okay, remember how the order in which the letters appeared really mattered, because it told me, you know, what corresponded to what, all right? And so we can tell that here, all right? I can tell that, you know, from triangle GHI to triangle G prime, H prime, I prime, all right, that's what tells me is that G corresponds to G prime, maps to G prime. H maps to H prime. And that I maps to I prime, okay? In this, is a reflection. Okay? Because, you know, it looks like it's just been flipped. All right? And if I put in a line of reflection here, you can tell that point G is equidistant from G prime. The same with I to I prime and H to H prime. Okay, and I'm using a curve here. Normally I would just use a straight line, but you know, I'm just kind of showing you the idea of a flip. So I hope you enjoyed this video, and we'll talk to you soon. Thanks a lot. Bye!